This is my Rube Goldberg that begins with a falling object and ends with a bucket being upturned on my teacher's head. A magnet of 1 Tesla falls through a coil with a radius of 0.25 meters in order to power a motor of 1 ohm. Now, finding the area and using the magnetic field, I found the magnetic flux, which was 0.2 Webers, and time as a result of the height of 5 meters is equal to 1 second, meaning that the EMF produced is 0.2 volts. Well, EMF is equal to the change of potential energy, so power is equal to V squared over R, meaning that power is equal to 0.04 watts. Now, in that 1 second, this cart is being pulled. The cart has a mass of 2 kilograms, and it moves a distance of 0.1 meters. The kinetic energy that's a result of moving the cart is equal to 0.01 joules, meaning that power, which is equal to joules over time, is equal to 0.01 watts. There's a loss of 0.03 watts in this situation as a result of friction in the motor itself. When the Bunsen burner gets pulled under this nylon 6 string that has a width of 5 millimeters, it begins to heat it up. The width of the Bunsen burner flame is equal to 0.02 meters, and the thermal conductivity of nylon 6 is 0.25. So with that, the rate of heat transfer has to be 1.244 joules per second in order to raise the temperature of the nylon string from room temperature to 268.8 degrees Celsius. When it melts the string, it will snap, and the tension that was up here and the force tension that it takes to snap nylon 6 is far greater than the force gravity that the sledgehammer is experiencing. We'll release the sledgehammer, which will swing a height of 1.75 meters in order to hit this bowling ball. The gravitational potential energy of the sledgehammer before it's released is 87.5 joules, meaning that kinetic energy when it hits the bowling ball is 87.5 joules. Now, using KE, kinetic energy is equal to 1/2 mass velocity squared. We get the velocity when the sledgehammer strikes the bowling ball is equal to 5.9 meters per second. Using the conservation of momentum, we have that the velocity of the bowling, with the sledgehammer moving backward at a velocity of 1 meter per second after hitting the bowling ball, the final velocity of the bowling ball is moving in this direction at 4.9 meters per second. And using kinetic energy equations, we find that the final kinetic energy, the total kinetic energy of the system, is equal to 86.535 joules, which is less than the kinetic energy of the initial system, meaning that there's a loss of energy as a result of making sound. Now, when the ball falls onto the ramp, it will pull this string. The ramp has a slope of 45 degrees, meaning that the 70 Newton force gravity that the bowling ball field experiences straight down is causing a 49.5 Newton force in the direction of the 45 degree angle, pulling this rope over a bucket on a hinge, which is also at 45 degrees. Now, the force, 49.5 newtons going in this direction, means that there is a perpendicular force acting on the bucket of 35 newtons, which means that using the torque equation of torque is equal to radius force sine theta, means that this distance of 0.2 meters times 35, which is the force, times sine of 90, because this is perpendicular, means that the torque that the bucket experiences is 7 Newton meters, which is enough to pull the perfectly balanced bucket over, dumping water on my teacher's head.